Okay folks, this is a prequel to our tutorial, and today I'm going to talk about this big lump of rock that sits out in the middle of Australia that we used to call Ayers Rock, but we now call Uluru. And the concept here is Uluru is nothing but an erosional remnant, or to use the correct term, an Inselberg, which is the German word for island mountain. It's an interesting concept, the idea of an island mountain, because it's not sitting in the middle of water, it's sitting in the middle of land. But it is sort of a strange mountain in that it's kind of sticking up out of the ground. So in tutorial we want to go into the concepts involved with how you would make such a beast. I'm going to show you some of the background history here. Start by showing you a beautiful aerial view of Uluru. A couple of things I want you to notice here is notice when you look down upon it, you can see all these linear features across it, which are quite interesting. And I want you to think about what exactly those lines are. I've been asked numerous times in the 25 years I've lived in Australia about Uluru, or Ayers Rock, is what I used to call it, and say, what is it? Is it a granite? And I believe the answer to that is quite obvious to you, that no, it is not a granite. It is some other beast. So here's a sort of history of the region, and this picture is showing us the Amadeus Basin 900 million years ago, and it's showing you two things. This Katachijuta, I don't know if that's how you pronounce it, another one of these cool Inselbergs in the region up there that tourists like to go to, and Uluru, which is this little box here. And what it's showing us is that we have some deformed basin, and upon that basin we're depositing some sediments, and then we've got a shallow sea where those things are now under deep water. And we could see how with time, during the Alice Springs orogeny, about 350 million years ago, we started to fold, these are folds here, and fault. And notice how these faults are lined up in a special way, that as the folding here is squashing this region this way, the folds are forming in relation to that compression. And if we compress enough, then we start to push faults, which are pushing older rocks up on top of younger. If we then follow that through, we can see that Uluru is now standing pretty much tilted vertically. And above it is what we call a thrust fault. We call it a thrust fault because the thrust is pushing these rocks up on top of it. So we could see how if we had bedding that was sitting quite horizontal, it's now standing straight up. And the finished product is that when we end up eroding everything off the top, except for that little bit of sedimentary rock, which is showing completely vertical bedding. And it's part of a larger fold. Notice that we have a syncline here coming down and back up. So this is a fold, and as you know, this fold used to come up and around like that, but that anticline is completely faulted off. And so we're exposing in both situations these Inselbergs, where we have sedimentary material that's standing up from the surrounding area. I'm not going to tell you more about this because I want you to do this in a tutorial, but I wanted to show you a really cool Inselberg that's quite famous, and the name is obvious. It's called Ship's Rock in Mexico, and it's a famous place because it does look like a big ship. If you look at it, we've got the desert surrounding it, and we've got this weird little line of stuff, and then this thing sticking up. Now this, I'll give you a clue, is not sedimentary. And one of the things that I want you to do in your tutorial is to contrast Ship's Rock with Uluru and to think about what Ship's Rock is. And this is a bit of a clue, this bit here. But with that, I believe we will stop. Thank you.